Hello friends, welcome to the video lecture series on artificial intelligence and machine learning. I am Dr. Dafda, and in this 27th video class of AI/ML, we will understand the breadth first search in artificial intelligence and we will also implement it in Python. In the previous video class, we understood the difference between the uninformed search and the informed search. Uninformed search is blind search, that is search without any knowledge, and informed search is heuristic based search, that is one that uses some estimate or best guess for the search. Here we will learn the breadth first search, which is a blind or uninformed search. Starting with the name, what is the meaning of breadth first search? See, as the name suggests, breadth means width. So breadth first means width first, which means going wide or going across for the search. First here means it looks at wide options first and not deep. And search, we know, means to find something, that is a goal, a answer or a solution. So breadth first search is a way to solve problems by looking all the nearby options first, or the wider options first, or the same level options first before going deeper. Okay, so let us start. Let us begin by understanding what breadth first search or BFS actually means. BFS is a method that helps us explore a graph or a tree step by step. It is very helpful when we want to find the shortest way from one place to another. Just like how we look for the shortest route on Google Maps. Now, why it is called breadth first search? Because it checks all the options at the same level first. That is, shallowest node first, not deep, like checking all the nearby rooms before going deeper into other rooms. Let us understand with a building example here. Imagine you are standing in room A. Then you write down all the rooms connected directly to A, say B and C. Then you go to room B next. From there you write down the connected rooms like room D and E. Then you go to room C and again write down the connected rooms like F and G. So what are you doing here? You are exploring room by room in order, not randomly. And that's exactly how BFS works. Step by step, in a straight and organized way. So in short, BFS explores things horizontally, not deep first, but across first. Okay? Now let us see how BFS actually works. We use a queue, that is a line, where we add from the back and remove from the front. And this is also known as FIFO, that is first in, first out. So in the queue, we add from the back and remove from the front. Let us understand using a simple example. This figure shows a tree with node 1 at the top, which is our starting point. Node 1 is connected to node 2 and node 3. Node 2 is further connected to 4 and 5, and node 3 is connected to node 6. We will now explore this tree using BFS step by step. Let us understand it using this table. This table shows what is in the queue, which is the list of nodes to be visited and which nodes we have already visited so far. In step 1, we start at node 1. We put 1 in the queue from the back. We remove it from the front, mark it as visited node, and add its children's 2 and 3 to the queue from the back. In step 2, what we will do? We will remove 2 from the front. So 2 is marked as visited, and we add the children of 2, that is 4 and 5, to the queue. So when 2 is marked as visited, its children 4 and 5 are added to the queue. In next step, it is the turn of 3, but 3 we can see has only one child, 6. So we remove 3 from the queue and add its child 6 to the queue. In step 4, 4 is visited and marked as visited, and as 4 has no child, only 5 and 6 will remain. In step 5, 5 will be marked as visited and 5 also has no child, so only 6 will remain and nothing new is added to the queue. And in last step, 6 is also removed, marked as visited, and the queue is again empty. So as we can see from the visited nodes column, we visited all the nodes in the order 1, 2, 3, 4, 5 and 6. And this is exactly how BFS works. Also notice how the queue column shows who is next in the line to be visited. That is 1, next 2, then 3, then 4, then 5 and 6. So this is like people standing in a queue at a shop. One person comes, goes, and the second one is added to the cube. That is first in, first out. So this is how BFS uses a cube to move level by level. This is level 0, this is level 1, and this is level 2. So BFS always goes wide first before going deeper. So here we can see level 0 is completed, here level 1 is completed, and here level 2 is completed, and therefore it is also called a level search technique. Okay, let us understand the time and space complexity of BFS. Although BFS is good because it always finds the shortest path, it has a big problem. It can get slow and use a lot of memory when the puzzle or the problem is large. So as the depth of this problem increases, the memory required increases exponentially. For example, imagine you are in a city and want to reach a shop. You check every possible road one by one and you will get the shortest path or the best path, but you will also spend time remembering all turns and streets you have already visited. So in technical terms, the time it takes grows like the order of b raised to d, where b is the branch factor or the number of choices. So you can say this is the branch factor, the branching or the number of choices at each step, and d is the depth or number of steps to reach the goal. So this is level 0 or depth 0, this is level 1, level 2, and so on. This means that if you have 10 choices at every turn and your goal is 5 turns away, the BFS may check up to 100,000 paths. That means you will require a big notebook or a very large memory to store the results. So technically, space or memory required is also equal to the order of b raised to d. So BFS takes a lot of time and memory, and that is why we don't use BFS for very large or very deep problems. It is better for small puzzles or mazes. Okay, let us see the advantages and disadvantages of BFS. In advantages, the BFS will always find the shortest way if all the roads or steps are equal, which means that it is always optimal, and that is the reason why it is good for simple puzzles. Next, it is easy to write and understand. Next, if a solution exists, BFS will surely find it. So it is a complete method. In disadvantages, we can say it uses a lot of memory that makes it heavy when the problem grows bigger. It becomes slow if the solution is very deep or far, and if you are working with mobile devices or small computers, BFS might not work well. So BFS is great for learning and small problems, but not best for very large or complex problems. And these are few real world applications of BFS. For example, it helps in finding the shortest path like the Google Maps. It is used in games like Rubik's Cube or 8 puzzle to find the minimum moves. And likewise, it has many useful applications shown here. Let us implement this example of breadth first search in Python. So this is the Python code for the same example that you understood in the theory, and the comments are mentioned and the code is self-explanatory. And this is the output. Let us again run the code and see the output. So this is the same table that we understood in the theory. Now for the same example of BFS, say I want to find node 6, then this will be the Python code. Let us run the code and see the output again. So these are the visited nodes and goal node 6 is found. And now say I want to find 3 instead of 6 in the example, then I will replace this 6 with this 3 and again run the code. So it will only visit 1, 2 and 3. Why? Because goal node will be found at 3 and the path taken will be 1, 2 and 3. Okay. So that is all for this video class. You can download the PPTs and the Python code from the link given in the description box. Thank you very much.